Hi, this is Chris Poor from AIS, and we are going over the 2023 Fissure Challenge solutions. I'll be solving them in order, so if you want to jump ahead, that should help you. The link to the challenge and this video can be found at fissure.ainfosec.com. Click on the link, and it brings you right here. Or it could be found in the GitHub README just as easily. You go to the bottom of it, there's a Fissure 2023 challenge section. Click on the link, it brings you right there. This is the first year of the event, so it was really all about setting up the infrastructure, testing it out. Not so much about a contest. Not many people really did it this year, but it's more of a learning opportunity for now. As a result, most of the challenges are pretty quick and don't require the use of SDRs or hardware or anything. It's mostly just links to websites from the Fissure menu items and a couple tabs in here that do stuff without radios. And since it's kind of tailored towards beginners, I thought it'd be interesting to bring in a small panel of people who don't really know anything about signals or radios or what I'm doing here, what do I do in general. So I brought three friends of mine. You guys want to introduce yourselves?
Hi,
Hi,
I'm Ashley.
I'm Travis.
I'm Ryan.
Very good, very good. Let's get started doing these things. Yeah, right. If you go to challenges, you will see a list of challenges. In order to solve them, to know if you did it right or wrong, you have to create an account and it will say correct if you get the flag right. If you don't, it won't tell you. If you make an account and you start doing these, the scores aren't going to be tallied in the scoreboard. That's turned off. The event's over. Okay, so let's just go through them all. AIS. So first one is find the MMSI for this sentence. Now, AIS, for those of you who don't know, do any of you guys know what AIS is?
No.
No, I
Nope.
do not.
The Automatic Identification System, I think stands for. It's what ships use to know what's going on. So, like, you know how planes fly around and they beacon where they are and stuff? It's the same deal for ships, so no one runs into each other and stuff. And you can find, websites that publish the information. So, like, these are all the ships in the world.
Oh my god.
Oh.
So, with stuff going on over here, it's kind of relevant these days. Get out of here. All right, so any kind of receiver prints out these sentences in this format, and you can decode them pretty quickly just by doing any kind of online decoder. I like this one because you can do lots of ones. It's kind of similar to GPS, and they got these little sentences that do things. Hit the code, and it breaks apart the message. And the challenge wanted the MMSI, the user ID. So it's this number. Paste it in. I already solved this. Very good. Let's log out and do a different user here. Test, test, test. So now when I paste it in, it'll say correct and it won't be green, but you'll know if it's wrong or not. See.
Okay.
All right, that's the first one. Second one, find the same thing from a signal. So if you download the signal and you use Fissure here, there is a flow graph. You guys don't know what flow graphs are, do you?
No.
No.
Very good. You're about to find out. So this is a GNU radio flow graph. It does a bunch of blocks connected to each other, and you can decode signals and stuff. So if I load in the file that I just downloaded, hit play, it prints out the sentence I just got. Since you guys don't really know what's going on here, if you wanted to see it, what it's actually doing. You can visualize it with these little blocks.
What's happening when you're hitting play?
Nothing right now. Didn't work.
Oh.
Okay. Sure. You guys got to repeat. All right. So this is a signal. What it kind of looks like. Just a bunch of squiggly lines.
Mhm.
And it's got data in front of it, data inside of it, and these blocks make sense of that data.
Hmm.
You're gonna get a lot of that in this video. So how it
Is
does
this
it, it's not that important. Go on.
is this still the ship beacon stuff, or is this something different?
So it's the same, yeah, it's still the ship stuff. So that's the signal from a ship. And what it does is it transmits on two different frequencies and it does like two different messages at once. And if you take that message and you look at it here, um, this is the one I captured. Uh, this first part is like to and from a ship. If it's like this, it's like going to a ship. This one here represents like what frequency it's on or something like that. And each section gives you like different pieces of information. This is the actual message contents. This is like the CRC and how much padding you have to apply to it. Uh, so these are this is ASCII 6 hex. So like each letter here that doesn't make any sense, like E1MG, but they correspond to bits. Normally, a letter corresponds to 4 bits, like ones and zeros. But for these sentences, each one corresponds to 6 bits. So it's a unique thing that a lot of people don't realize. It makes it harder to decode these messages.
Hmm.
Anyways, you take that message and it's just 1, 2, 3, 4, 5, 6, 7, 8, 9. And you can get latitude and longitude, and there's all different types of messages. It's a whole standard out there kind of that people follow. You can encrypt the messages. You can spoof them. You can transmit them. You can make, like you see a lot of times, people transmit these messages and it makes it look like there's ships in the middle of Africa or something.
Mm.
All right. So if you paste the value, incorrect. There actually might be 2 messages in that file. Yeah, there are. So there's the second one here. Cool thing about this one is you do multiple messages. This one, yeah, this one's got a different value.
Why would there be multiple ones?
So they do it on 2 different frequencies for different reasons.
Mhm.
I guess different types of hardware will listen on different types of frequencies, and there's a lot of like people trying to vie for the same frequency space. So if you have 2 different things going on at once, you can like say, I'm only listening on this channel, I'm ignoring every other traffic on these
Mhm.
other frequencies. So it just makes it easier to receive the information and transmit it.
Okay.
We're learning a lot about ships.
Yeah, why is this only ships?
Correct. It's not just ships. Like they'll use it for land things around water, like navigational aids. They'll, or if like there's like a natural disaster or something, or if someone
Mhm.
spilled something, they'll say like stay away from this area. They'll broadcast
Uh,
information. But okay, those are the first two. Let's keep it moving. CRC calculator. So when you have these messages with these bits, there are these things called CRCs, checks, cyclic redundancy checks, and they make it so that uh, you can be sure that the content of your message is accurate. They go like towards the end of the message. It's like a little code that says you did it right. And if it doesn't line up with what the rest of the message contains, you'll know if it got like an error receiving stuff. So I'm given two hex strings with CRCs at the end, and I gotta find the like the formula, the polynomial used in the algorithm to calculate that value. So a lot of this is like reversing signals and messages and data. And in Fissure, we have some tools to help us make sense of this. And I have two messages that and I have to figure out what the algorithm is. The polynomial. That's the first message. Here's the second. Again, this is all in hex, so these represent like bits or something. You don't really know what. It's just random bits, it seems like. And I said it was a 16-bit CRC, so if you take the last four out of this message, put them in here. And I have this little tool that, given two messages and given two values, it will spit out what it thinks the polynomial is. It's reversing the process that you would normally do. So normally you would feed these bits into some kind of like shift register, some kind of thing that manipulates them. Uh, it's like a key and a lock kind of. So like you're passing these bits through a very special set of manipulations that are, set up by this value, and it gives you an output. How many of you are following me, what I'm saying there?
I think
Uh,
mostly.
yeah.
Okay, good. Let's keep it going.
So is the whole point of this to demonstrate the value of the Fisher app or whatever it is?
Right.
These
So
are
like
all, yeah.
so if you decoded a message from some device and you have no idea how that CRC is calculated, you can't reproduce the signals because every time you transmit something with a bad CRC at the end, it'll reject it. So nothing you send will get through to the device. So you can't hack anything.
Hmm.
But once you know how it works, once you find this value, you can calculate it for any message.
Okay.
That's what the second thing is, I think. For any Z-Wave message generated from the Packet Crafter tab, find the name of the algorithm used by the CRC Revenge in the CRC Calculator tab that produces the same CRC result. Okay, so I'm saying there's a Packet Crafter tab here in Fissure that gives you example messages for different protocols. So like if I have a Z-Wave message and a certain packet type, it has all these fields and all these bits, and at the end there's a CRC here. And if you put them all together, you get this giant message. And the challenge is asking me what is the polynomial name or the algorithm name used to calculate this result. So here's a example message, and you take the the 2 bytes at the end off because you're trying to find the thing that gives you that result, which was CA C0. And you can have different widths of CRCs. This is 2 bytes, 8 bits. Or actually it's 16 because it's 4 here. And there's all these predefined algorithms that people commonly use to calculate values. And they have these polynomials that we like found down here by default. So a lot of different things use the same formula, the same algorithm for finding these values. And I just found that one by accident. Okay, so we had to find the one that gives us that value, and it's that one, obviously, but other ones will give you different values. And those are the wrong ones. So this combination of everything gives you this value. And you can use it to generate any Z-wave message. And find that, put at the end. Yeah, right. So it's asking you for the name of it. Let's just type it in here. Oh, there you go. Any questions about that?
I don't think so.
No.
Very good. Very good. The data viewer tab. So we're still working with data here. Find the flag in the bit stream. So this is the file. It's just a bunch of ones and zeros. And I have this data viewer tab, a couple tabs over. You paste the bits in, you can convert it to hex. And it looks like that. And so there's a flag somewhere in these bits, and you can do different manipulations on them to give you different results. And if you're just looking at these bits, you'll notice that like these are all like A, 9, 5, 6s and stuff like that. There's not a lot of variation. And you'll never see 3 ones in a row or 3 zeros in a row. So that tells you that it's Manchester encoded. It's a type of way of ordering these bits to make it easier to receive them. So like if they change they change constantly and they're never 3 in a row, it's easy to synchronize with like a clock or something. So that's what they kind of do it. So if you Manchester decode it, you'll get you'll get like half the number and it'll be a little more sensible. You'll get more variation going on here, but there's still no flag. So what you can do is you can do more operations on these bits. They're differentially encoded. So like if you take 1 minus 0, that's a 1. If you take 1 minus 1, that's a 0 or something like that. Like if they change state between one to the other, that's how you tell if it's a 1 or a 0. So if you hit this differential button and you go to hex, it gives you more bits, and there's a flag in here. It says Happy Hanukkah. This was all in Christmas time.
Nice.
What is a flag exactly?
So these the Fisher challenge is a capture the flag event. So when you're working in cybersecurity and things like that, uh they hide these flags in files and data and things like that, and you got to find them. And this this software here is CTFD, which stands for like capture the flag daemon or something like that. And it's just a contest that people do in this type of work.
Okay.
So once you get the flag, you paste it in here and it tells you if you're right or not. And it keeps track of your score. A lot of conferences and things like that host these events. throughout the conference. So people work on them while they're listening to other stuff, and it's just a fun thing to show off your stuff.
The flag's kind of the hidden thing you're looking for in
Right.
this case. Okay.
What you just did with the zeros and ones, is that the only place you find flags, or is it in other
All
things
of these
too?
challenges have flags, and they're
Okay.
all different things. Sometimes they spell
That's
out
cool.
like, I don't know, flag. And there's different things you can do to search for them. There's different techniques people use in these kind of events to have better success. Kind of that sidestep what the actual challenge is doing. Like you can just search for flag or something, and maybe you'll find something in a file. All right, so next one. Use the data viewer tab to find the protocol subcategory that is attributed to the bits listed in the included file. Enter the subcategory combo box as the flag. So this, we got more bits, and it's asking us to find out what they are, what kind of message. So I have this table down here that will take the message and do like a reverse lookup for my. So if you hit apply, it'll take those bits and apply it to things in my library. And if there are extra bits, so it doesn't match up perfectly, this is where like the extra bits go. And you can click on them and it converts it to hex and stuff. So it wants to know which message these belong to. And instead of, I mean, I could build something that goes through them all and just finds the thing that matches up the best. And that's probably what I'll do someday. But for this challenge, uh, you just kind of go through all of them and you see like which one works. And the answer is this one, I believe. It's the same thing we were looking at before, the same protocol, Z-Wave. And it's a color switch message. So I use this for a light bulb, a Z-Wave light bulb. Like you can change the color of the light bulb and make it brighter and do stuff. So this is the actual message. These are the bits that get sent to do that.
And you know this one's the right one because it doesn't have any
Right.
extra listed. Okay.
Everything else in my library doesn't match up. It's like
Mhm.
the exact length of the bits. Certain messages are variable length though, so this kind of thing wouldn't work for those.
Okay, I see. So you were looking for a blank extra tab there, or a column.
Yeah, and you can kind of like see if certain things make sense. Like this will be a length field, and if you actually calculate it out, like the rest, that value matches the rest of the remaining bits. So and other things like these fields will tell you if it makes sense. Like if these are RGB values, red, green, blue,
Mhm.
they fit within there, just some context, then you know it kind of matches up better. Yeah, keep it going, keep it going. That's that one. Use the data viewer tab to find the name of the field, excluding the CR field that is different between the two messages included in the attached file. So it's giving me two messages and it wants to know what's the difference between them. So if you paste them in here, if you apply the same thing, I think it's the same thing. Yeah. And it wants to know what the difference is. It's this one. Everything else is the same, except the CRC here at the end. It's asking for the name of it. So G value.
Mhm.
Here you go. Any questions about this little tab I got going here?
Nope.
Oh, yeah.
I'm gonna build it out to make it do things and then have more automation. So it'll kind of do all the things I just showed you on its own without you having to cycle through anything. Garage door opener. Find the code for the 10 position dip switch for an older garage door opener remote by inspecting the included signal. So old tiny garage door openers have remotes and they have little switches on them that you can set a code, right?
Mhm.
And it's asking for what that code is on the remote and on the garage door, I guess.
That's
So I
based off of
download,
the signal.
yes.
Okay.
So this is a signal from my garage door remote. You see just a bunch of pulses there, but if you zoom in on it, each one looks like this. And there's a code to it. The pattern's pretty straightforward. It's like this is a 1 or 0, and that's a 1 or 0. So it'll be like 1 0 0 1 1 0 1. And if you're like generating the signal, like this is 3 times the width of that, and then there's like a space between here. So if you represent them as like small little chips, small little ones and zeros would be like 1 0 0 0 0 1 1 1 0. So that's one way of transmitting the stuff. Anyways, the code. Let's try it this way. 1 0 0. This is on-off keying in a way where it's just the presence of a signal dictates what the values are. Sometimes they'll say like this is a 1, this is a 0, but if they're in a bunch in a row and they have different widths, sometimes the widths tell you what it is.
Mm.
Yeah, that's it. Find the FCC ID for the garage door opener remote in the gallery tab. I have a tab here that's just a bunch of pictures for things. So like if you're doing stuff and you want to keep a record of it, you have notes or something, you can throw them in here and someone who has no idea how a garage door opener works, they can just look at these pictures and get a little idea of what you're doing. So every device that transmits something in the US at least has a FCC ID, and they go under evaluation before they release the product and stuff like that. So there's a code associated with each one, and you can find information about the testing of that product. So you'll know information about the protocol. You'll find like what kind of modulation type it has, what kind of frequencies it transmits at.
Mm.
And it'll give you test reports. So this code is A9K X multicode. You'll see it up here too. And in here. Good way to look up a device if you know nothing about it. Any questions about FCC IDs?
Those are just so for anything that like produces a signal, it has a FCC
Yeah.
ID.
If you look at anything you have on your house and just look at the back of it or a label somewhere, you'll see it. What are we doing? That's pretty good. That's it.
Looks fairly easy to hack a garage door opener based on this.
So the old timey ones, it is. And I built a fuzzer that goes through every combination and it takes like 5 minutes to do it. So if you know what frequency it's at, or you could transmit at several frequencies at once to like spam everything,
Hmm.
it doesn't take that long to break it. And I actually have videos of that kind of thing. If you go to my Twitter, You'll see a garage door opener video
Hmm.
of me just cycling through everything.
What
How
makes
old
the
is-
new ones harder?
Yes, sir.
The new ones have rolling code in them so that no, it's not listening for the same message every time. And
Hmm.
it's
Changes it up.
it's like your car remote. So you can't just send the same message every time for your car. It'll change it up each time. But people do stuff to get around that, but it makes it more complicated.
How old is old timey, or when did they
I'd
approximately change
say
it?
like in the 90s, they started switching over, like mid 90s, early 90s. Anything in the 80s, definitely had the older ones probably. And they got like home link now. Your cars can like have your garage door opener signals and stuff now
Yeah.
programmed into their mirrors.
Mhm.
Okay. Next one. J2497. This is a kind of an obscure protocol that not a lot of people know about. What is the data field in the attached J2497 signal? So we got another signal one. So these signals aren't actually wireless. They're on a wire, but you can pick them up if you're next to tractor trailers and big trucks. And there is a flow graph again for this kind of thing. This is something I worked on, and we did a DEF CON talk about it. You can receive these messages, but we also proved that you can transmit them onto these trucks to do different things under certain scenarios. So this decodes the signal. Let's get that. Repeat, yes. This is something I built. If you look at it's a couple messages, I think, or maybe just one message. It's one message repeated over and over again. And these things are kind of complicated. You have like a preamble. There's a whole GitHub project on this if you want to learn more about it. But this is how you get the ones and zeros. Like this is the main part of it that you want to decode. And this thing is printing out the same message over and over again, most of the same message. Well, this is changing up a little bit. You'll see like if it's the bad message, it'll say bits missing or something. But most of them say you can toggle the sliders and stuff. Most of them say this. And I think that's what the challenge was asking for. It's the data field. Yeah. So you probably have no idea what I'm talking about with any of these messages. I didn't really explain what they are and what they do, but we don't have time for that.
Okay.
But if you do want to find out more, the next one will help you. What was the name of the DEF CON 2022 presentation on PLC for trucks? We just do DEF CON 2022 PLC for trucks. The name of the presentation was trailer shouting. That's what I'm looking for. If you do GRJ 2497, that's the repo that code is from that I just used. And it will tell you about everything, how it all works. So trailer shouting was the answer. There's two DEF CON presentations. There's one from like 2020 about receiving and one about transmitting in 2022. Trailer. Questions about that one?
Nope.
That one you have to have, there's different ways of doing it, different hardware you can use, but I would drive on the highway and I would put this up against the window. You can just collect them as you're driving by the trucks. And it controls things. It's mostly going to control like the little ABS lights in the cab, but it can also influence the brake controllers under certain circumstances. So that's kind of why it's crucial that
Wow.
people can't inject stuff.
Yeah.
All right, Morse code. You guys know what Morse code is, right?
Mhm.
Yeah.
Find the message. There's different types of Morse code, but they all have they tend to follow a certain standard of like what the spacing is between the dits and das should be, what's the spacing between a word. So instead of just going through and saying dot slash for everything, you can press a button in Fissure that'll do it for you. Peace, love, joy, hope. It'll print out a message.
Oh, okay.
And there's settings in here that you can see what the spacing is between each thing, how much tolerance. Because if like someone's doing this by hand, there's gonna be some error. If
Mhm.
someone's doing it by machine, it's probably the same every time. And there's different online decoders and stuff in Fissure menu here. This was peace, love, joy, hope. All these CTF events I go to, a lot of them have Morse code challenges, so this helps me out. It saves a lot of time. Peace, love, joy, hope.
Is it used that much in the world
Morse
today?
code?
Yeah.
Yeah, it comes up.
Yeah.
I mean, it's really just it's not used every. It is and isn't. Like it's big in the ham radio world,
Mhm.
and there are certain applications that use Morse code as a way of getting messages across that most people will be able to receive.
Mm.
Like those ships, in some cases, might transmit a Morse code message under like a certain scenario. Um, but it's just like a universal thing that most people will know. Packet crafter. What is the new CRC value on the north-south velocity field change? ESP. Okay, so it's asking me to ch- uh, look at an 80 ADS-B message, which is like the message transmitted from a plane, and a specific type of message here, one velocity, ground speed. In that this tab, which I was looking at earlier, mode has this one, and it wants to know what is the new value for that CRC when the north-south velocity field is changed to all ones. So you find the field down here, north-south velocity. There are 10 bits. Change them all to ones. And then this packet crafter will calculate the CRCs when you change the values. So if you hit calculate, that changed. So that is what it's looking for, I think. It's useful for building messages and constructing sequences and copying them into other things. I'm going to make it so that you can click a button and it'll do an attack for certain types of messages. So you don't have to enter it in manually. Packet crafter. But there are whole videos about that thing, so we don't have to go over it all. Any questions about what I just did there?
Nope.
Sweet. We're going pretty slow. Let's keep it up. Find the RDS flag within the RDS one. So this is another signal guy. RDS is like FM radio. It's radio data system. It's how you get song information and artists for a lot of your stuff in your car. as you drive around. There's different types of FM radio protocols that go on, but this is one of them. There's a common tool that people use to receive it and transmit it. There's a couple different ways of doing this, actually. One is to use a flow graph. It's pretty complicated. It has a lot of blocks, as you can see. The other, there are tools that people already like to use for decoding this kind of stuff. So you can't really make much sense of it just by looking at it. But if you load it in, it's recorded at one this, and you enter any value here. So this is GQRX. It's just like a signal viewer. It's got a waterfall, and it has a couple features built in. One of them is RES decoding. You check that box. You do some kind of FM demodulation. You hit play, it plays the signal. If you hit enable RDS, it will decode it for you.
Hmm.
And normally there's audio that goes along with it, and there actually is audio if you like turn it way up, but you can't hear my sound anyway. It doesn't matter. The audio is not important. This is what's important, the text. Reboot car. Reboot car. Correct. So if you use that flow graph, what you do is you would change it from all these radio blocks. You do a file source, and then oops, this is not the. It's the big one. Where are you? File source, and you have to resample it to match whatever frequency I recorded it at. And sometimes just changing the sample rate will impact all these other blocks. So if you just do like 1 million divided by the sample rate here, you'll get the same answer, I think.
Is there any benefit in using this flow graph as opposed to the first way you did it?
There. The GQRX is nicer. It's not as much work.
Hmm.
You can just tune on it. You just click a button. You click right on it. Like you'll see an FM station. I could pick up stuff right now if I plugged in a radio,
Hmm.
and you'll get all the information. This you have to you got to do the same thing, but you have to use these sliders, and it's kind of really tuned to this particular application. So there's a lot of if you had to tweak something, it might be a little harder.
Hmm.
But there's the flag again. They work just about the same. No, they work good. All right, keep it going. SIG-MF. So when you record these signals, if you'll get these files here and you won't have any other information with them a lot of the time. People record stuff and it's useless to people if you don't know things like the frequency and the sample rate that the thing was recorded at. So they have these metadata files called SIG-MF. That's the standard that recently was created that people are starting to use more and more. And there is a website, IQ Engine, which has example signal files and some SIG-MF tools. So the cool thing about the SIG-MF is that you can add annotations, so you can like put comments with your data, and uh, you'll know a lot more about how it was recorded. There is a thing here. It's a SIG-MF validator. So it's metadata, but it has to follow some kind of standard. So there's a GitHub for it. It tells you how it works, which things are required. And the challenge was saying, what is the position number of the syntax error? So here's an example metadata file. And if you copy and paste it into the validator, it'll tell you if you did it right. So you can do things like the author, the license, the, sample rate, frequency, what antennas you use and stuff. Copy and paste it into here. It'll tell you there's an error at position 1236, line 38. There's like a period or something that's not supposed to be there. 1236. Here's another example. What is the value for the core description field in the SIGMF meta file? So there, when you record a file, it's SIGMF dat / data is the signal, and then the metadata is .sigmf / meta. So Fissure comes with an example file, just a signal. And if you click the SIGMF button, it opens that metadata file for that data file, and it's asking for core description. Any questions about what this is all about?
Nope.
It's really hard for people to agree on one standard for everything. So you'll see people do their own style. Different types of recording equipment will have metadata files that don't match with anything else. It's all very specialized.
Hmm.
CPMS. This is another signal. This is your tire pressure sensor. So on your car, it's transmitting signals to tell you how much air is in it, since you can't really have a wire going to your tires. It's normally in the valve stem. There's a little radio. And there's different ways of doing it. There's lots of different protocols that the way the message is structured, how the signal is formed and stuff. This is just one example. This is from my Prius. 4 signals. Each one's from a different tire. And I have a tool that does it. These standalone flow graphs are just things that I've used in the past that I like for quick reference to try out. It should already be set. Easy.
Are those
Get rid of
powered? Do
that.
they have power to them or?
They have little batteries in them. They last for like 10 years or so.
Huh.
So sometimes you'll see warnings that your battery's going, or the light will come on when it's
Mhm.
you have no idea what's going on. And sometimes you gotta replace the whole thing or put a new battery in. Let's try it again.
That's what's wrong with our tire right now, Trev.
Yeah.
They don't have passwords on them or anything, so you can spoof them pretty easily. So that's the 4 signal coming on in real time. And what you can do is you can adjust these these values here, these sliders. And the way I do it is I make a little amplitude threshold around the signal. So that's what that threshold value is. It's a line that goes across to just tag the start and stop of a message. And then it decodes the contents between the start and the stop. And it's printing out a bunch of messages. There should be 4 different things. So this PSI is what we care about, I think. 37, 17, 34, 37, 17. Stop it. I think I want the lowest one, which is 17. Yep. So that's kind of a fun thing. There's a video I made of me injecting it into my car and make the light go on. You can't really do much to the TPMS. Like it goes into kind of a protected component. It doesn't talk to anything else. So you can influence that small piece, but you can't influence the rest of your car really unless your car reacts to that in some way. But most of the time, it just turns the light on and off. Well, you could build something around a traffic circle that just receives tire signals and transmits them instantly and have everyone have their lights come on
Jeez.
pretty easily. There's other software for decoding it. Like there's for all the different protocols that people have made. Let's not do that though. TSI. There's a new tab here that does it's okay. This is the signal conditioner tab. It splits large streams of IQ data. So if you have a signal file that has lots of signals in it, this thing splits them up into individual files. And that's not as easy as it looks. It wants to know the number of samples for the fourth signal file after the strip function is applied to it. Or one each. So this tab over here is what we're talking about. There's a file in there called one each, and it has 15 signals in it. Do I dare hit the preview button? I'm not sure if this is, it wasn't working one time. Oh, I don't think it was. Anyways, and it wanted me to do it with, I think, the default settings here. I can view it with the other tab here. I think just how this laptop was set up, it wasn't working. I gotta fix it. Yeah. So if you want to know what I'm talking about, conditioner data input. There's 15 different types of signals and they all look completely different. They all do different things. And it's hard to break them up if within a single message you have things that do this, or you have things that do this. So there's different techniques that you can apply to get the best result. It'll split them up. So I found one that gets all 15 pretty well. And that's what I was doing in here. And if you look at the results of them, it's just all of these isolated into their own file. And if you hit the strip function, it gets rid of the noise. It gets rid of anything that's before and after the signal. Strip all based on the amplitude. It's like that tire thing where I have just a line that ignores everything before the signal and everything after. And it wants to know the number of samples for the fourth file, which is that value. Again, we're not gonna go into these. There's the whole videos that I'm making about these things, and you'll go into depth about them.
So
The
this is
next tip, go
kind of
ahead.
just have a complex signal and try to start figuring out what it is. That's the idea.
Right. So Fissure is an RF framework that lets you, it's kind of made for reversing unknown signals, things you don't know about, as well as things that you do know about and tools that you already have. So if you have an unknown signal in the wild and you're just recording and you have a bunch of other signals, you're gonna get them all. And if you want to figure out which one's important, that's what this TSI tab, this target signal identification tab is. And eventually it's going to be automated or semi-automated, and you'll have something that constantly listens, splits up signals as it gets them, spits them out into individual files, then does analysis on those files.
Hmm.
So here are the 15 files that I have, and you can do different operations on them in this tab. So if you select all of them, it'll do everything. Does it want it for all files? Download the. He wants me to download a specific file. Silverado fob 314 1 meg. So Fissure also includes example files that you can download through an online archive. I think it wanted this. This is from a Silverado key fob for a truck. Click download, and it downloads them. And it wants me to analyze what I just downloaded. It's right here. You hit start. And it does all the operations that I had checked here. And it prints out just statistical values for things. And you can like plot things and see trends and get rid of bad data if you want. That's what this tab is all about. So you get these values and you can plug them into classifiers that do artificial intelligence, machine learning type stuff that need statistics fed into them. So that's the point of this. So if it's automated, it'll get the signal, break it up, pull out the good values, feed them into something that tells you what it is. And it's in the works. Like I have this.
Mm.
It's not released to the public yet, but it will be. It's done. I just had to make it work for every operating system and every version of Fissure I got going. What was it asking for? Find the standard deviation. So there's a thing called standard deviation. Copy and paste it. That's the flag. I'm not even going to ask you if you have questions about that one because there's a lot to unpack here. I'm not teaching you how this works.
Fair enough.
Good. There's a whole tools section here that is mostly websites to places. Some of them are actual tools. Since I wasn't using radios, a lot of the Fissure tools use radios, so I couldn't do a lot in this event. There's a flag in this signal. It says use in Spectrum, which is someone else's tool. It's not my tool. Spectrum. So you plot a signal, looks kind of like this. You have no idea what's going on. You zoom in. There's just a lot of junk. You load it into Spectrum. It does a waterfall, and you can slide these values around. And eventually, if you get it just right, you'll see the flag in the signal. It says holly jolly, festive, bright cheer. So what people do is they'll put images and things in the signal. So it's not really in the data, it's just in the frequency view of the data.
Hmm.
If you know what I'm saying.
Why would they do that?
There's no good reason other than to make fun of people who are looking at it. Like in Ukraine and stuff, they would put out messages to the Russians or whatever, I think, and they would say stuff in the messages.
Okay.
Or if you're doing CTFs, they'll put images and QR codes and they'll advertise stuff. I mean, you're not allowed to just transmit anything you want on these frequencies for the most part. It's against the law. But certain ones you have more leeway, certain frequencies you can transmit whatever you want. But it's not a good way of getting data across to anyone.
Mhm.
Holly jolly, festive, bright cheer. I think or something like that, right? Holly jolly, festive, bright cheer. Christmas. Crypty. There is a wave file here. And it wants to use Crypty to figure out what's in the wave file. So there are different types of decoding that you can do on this website. You can type in data and apply an algorithm to it and get an output. You can encode and decode messages. The WAV file has a tab code, and if you play it with like Audacity, and you zoom in. Do any of you guys know what a tab code is?
No.
No.
So if you're in prison or something and you want to communicate with another inmate, there's a code you can tap on the wall to let them know what you're saying. And it takes the alphabet and it puts it in a grid, like a 4x4 grid or something like that, or a 5x5. There's 26 letters. And if you uh, do like one tap followed by another tap, it's like XY coordinates on that grid. So 1 1 is A,
Okay.
and you can feed these values into this website. Um, and it will spell stuff out like that. And I'm not gonna do this all because we're running out of time. But so dot A 3 1 L, and there's another 3 1. So you just keep doing this. Or you do 2 spaces between a word if you want. And I think it spells out all I want for Christmas is off this roof. Something like that. Oh my. Yeah.
Mm.
It's just a fun thing. I mean, audio and RF signals, they're kind of related. You do a lot of processing on this. You can filter audio, you can filter signals. It's kind of the same thing in a lot of ways, even though it's a different medium and it doesn't have the same properties. You can still work with the data kind of the same way. Sond Hub. This is a fun one. Find the 8-digit ID for the easternmost radio sonde according to its last recorded position, launched from Bismarck, North Dakota in the month of June 2023. Very specific. So you guys know anything about weather balloons?
Not really.
Yeah, not really.
Oops. Did you know that they do it twice a day everywhere at the same time in the world for the most part? And they just let them float around and don't care where they land.
Really?
Yes.
Huh. Didn't know that.
People complain, like farmers complain that the cows will eat the parachutes and get in their stomachs.
Huh.
So they're big balloons and they get launched in the air and they float up, then they pop, then they deploy a parachute and just kind of sail and record the weather.
Mhm.
This is what's going on the past 12 hours.
Oh.
They do it out of airports. Each one of these dots is a receiving station or an airport, and each parachute is a payload. And if you click on them, it'll tell you their path and where they are. Oops. There's a lot of stuff going on here. And you can chart their altitude. There's graphs on this website. It's nice. And it's got a history of everything. And it wants to know about Bismarck, North Dakota. If I get rid of this. You can launch, you can enter the year. I think it's a June 2023. Yeah. And what it will do is it will show you everything that happened in June 2023. These little dots are different days, different balloons. You can see the whole flight path of this balloon. And this is the idea I'm talking about, I think. I want. Any questions about weather balloons? I've done this. I've set up a station and recorded stuff. I never actually recovered one. I wanted to do that. They've landed within like a mile of my house once, but I couldn't get it.
Couldn't get it. You couldn't get to it.
Yeah, it landed in like a swamp. So
Oh,
what am I gonna do?
Yeah.
They stopped transmitting after like a day or a few hours.
Didn't last very long then.
No, but you could probably charge them up or make them transmit again. There's no password on them or anything.
Hmm.
But they just have like temperature sensors, humidity sensors, that kind of thing.
mhm.
Whenever they do like a space launch, they'll send up a bunch of them to get a feel for the weather. Sound exchange. Trim the silence between the waves to reveal the flag. So again, we're working with sound. There's a lesson on this tool. Fissure has a bunch of lessons for doing stuff. One of them is sound exchange. And I guess I can enable my sound. This sucks. So if we open a terminal and say play, this is like I don't know, like a 5 minute, 5 minute sound of me just coming in and out saying something. You can't make sense of it. And it's asking you to get rid of all the silence in between all the audio so I can actually hear what I'm saying. So this tool will do a bunch of stuff to audio files. One of them is trim the silence. I guess we could do something like this. So if we do, this is called socks.wave. Just keep it out.wave silence. And you play these values, and I think eventually if you just set them real small, it'll do what you want it to do. I don't remember quite how it works.
The flag is don't work on Christmas.
Don't work on Christmas. You guys hear that?
Mhm.
Excellent. Stop sharing my sound now. So that's the fun tool for doing a lot of different things. You can normalize signals and convert it to different things and play filters and whatever. It comes up a lot. Laura, what is the NORAD ID for the Kepler 18 satellite? Satellites. You can visualize them. I added a bunch of tools that aren't listed here. This is kind of an old version of Fissure, but one of them that's fun to look at is this Leo visualizer. At any given point, you can track the satellites that are out there in space, the ones that are being tracked. And this is what they all look like for low Earth orbit. There's different orbits, different satellites in different orbits. So there's a lot of stuff going on. My computer probably can't handle it. There's so much going on. And it also tracks debris, space junk.
Hmm.
I don't know. I might be able to find it right in here, but there's other look up things that you can enter. Kepler 18. So somewhere in here, there's a satellite flying around. Is that it? Here's the one. Click on it, and they wanted the NORAD ID. But you can look them up and figure out where they are on the Earth, where they're going to be, what they're pointed at. My computer is struggling. Let's get out of here. Go faster. What the frequency megahertz? So this is air traffic controllers. You can figure out like what frequencies they operate at. You can listen into them. Fissure has some resources for that. They point to other places. VHF. He wants to know for a particular airport, KSBG weighted. Get out of here. Man. Sometimes there's ads. Okay. He wants to know the frequency of the ground tower. So you can click a button and it'll listen to the actual audio so you can hear the planes going off. This is the answer, I think. Nope. Yep. All right, fun times. You guys ever listen to the plane audio while you're flying around?
Sometimes on the plane, yeah.
Sometimes it's best not to know.
Yeah.
I feel like I wouldn't want to know.
All right. Point to point. So this is a fun tool that I found. Point to point. So if you have long distance communications, you get these two units and you point them to each other. They need to be looking at each other to get a signal. So like if you're out in a remote area or something and you want high-speed internet, you get these things. Ubiquity has a nice website that you can add points down and it'll tell you if you have a line of sight based on the heights and the angles uh, and what device you're using. So these units are these dishes, the air fiber dishes, and I'm giving you coordinates for two locations, and I'm asking you what height it has to be to get that line of sight. It's a relevant problem, especially if you're attacking something that's far away, or if you're setting it up in your neighborhood and you want to know, is it doable? Like some guy wanted to do this across the city, and he had to figure out his topography.
Hmm.
So you type the two locations, hit enter. Come on. It's loading. It's not the right locations. Um, did I not? Maybe I hit enter after I do it. Here, first one. There we go. So this is the scenario I'm talking about. You're like on a other side of a mountain, and I want to know if one's 60 meters up in the air, how high do you got with the other one? So you keep raising it, and eventually it'll tell you. Go to like 260. You just keep raising this value, this height. Come on. It usually works pretty fast, but my computer doesn't like being recorded. 2, 6, 0. And it will, as you get closer, it will show you what the data rate is and stuff once the link is good. There we go. It's somewhere around 270. It starts to come in. There you go. 271, I think it is. And it'll like show you like what hill is bad, and it'll give you an estimation of your throughput and stuff if you open the right stuff. It's still loading, I think. Fun tool. Question about that?
Nope.
What Belkin model number with that chipset is vulnerable to a pixie dust attack? So Wi-Fi has these things, has this thing called pixie dust, which is a way of getting around a password and things like that. Wi-Fi. And I have a list of devices that are vulnerable to this. A lot of tools will check if it's vulnerable or not. Belkin something something. Yeah. RT3050 chipset. So RT3050. Right. Belkin. He wants to know what model. So what's this model? So this is just a list of vulnerable devices. And different wireless chipsets in devices have different vulnerabilities, and different firmware versions and things impact that. Very good. Let's keep it going. Ship tracking. There are tools for crew, like detecting ships, which I kind of already showed you. One of them is a cruise mapper. This is every cruise that's going on.
Well,
You can also Google it to get this answer. I'm looking for. I don't know how long my computer's going to last before it grabs that. Island Princess. There are ads on this website too. And they want to know the departure date for like Valentine's Day coming up for the port. What's on the port? Sydney. Sydney's the answer. This isn't too important to anyone really. Sydney. Bluetooth class of device. So Bluetooth has these different fields inside the message. And one of them is class of device will tell you what kind of device it is. And I have a lookup, I think. There's a bunch of tools you can use. There's a list. There's BT Classify, I think, does it. This website has a list of them. 908. He wants to know. So if you see this code, you can do a lookup. and it'll tell you what it is. Or you can use a different tool and it'll print it out. This one is a thermometer. That's what I'm getting at, I think. So it's useful if you build something that listens for Bluetooth devices and you want to know what's in the area. Is it someone's phone? Is it something, I don't know, a personal wearable thing? And you can kind of target based on that field or some kind of ID inside the message. Cellular towers. I'm getting bored with this. Okay. You get a cell 13 of a Verizon eNote B tower. So knowing where towers are is useful for a lot of reasons. One of them is like people will spoof the towers to get your phone information, your IMSI values, like IMSI catchers they call them. And it's just a unique identifier that lets you do things to your phone that if you didn't know it, you couldn't do it.
Mm.
And the way they work, they do different things, but like for 2G signals, they'll just they're very vulnerable to attack. For like 3G, 4G, they're not as vulnerable, but there are downgrade attacks that you can do to put it onto 2G. There are other different types of attacks that'll get it. Sometimes they do man in the middle attacks where they spoof a tower and they just forward your data. Sometimes they're just stronger than the actual tower. And that's good. And you'll hop onto them and you won't necessarily feed your data, but they'll still pull your phone information while you're on them. And what am I looking for? I'm looking for cell 13 of that eNote B. So that's like a tower or an antenna on a tower. And you can search it. And there's ads on this website. Search. There is an IMSI catcher in Fissure that will pull it off your phone for LTE signals. I've tried it on my phone. It works. It will, if it's stronger than your tower around you, it'll kind of kick you off and you'll jump onto that and it'll pull off the information. It doesn't do anything other than that. What did it want to know? He wanted to know the cell identifier. This. So if you have phone apps that give you all the information for towers in your area, you can kind of tell if the signal you're receiving is different than it is in the tower by like the strength of the signal and stuff like that. And these maps help you figure that out. It'll tell you like what it's transmitting at, what frequencies, where it's pointed even. It'll plot it on the map.
What kind of information can it like doing that pull off of your phone?
Your phone, phones are vulnerable to a lot of things. If you have that information, you might be able to send text messages and stuff, which can infiltrate your phone and deliver agents, and from there they can pull off like anything on your phone.
Oh,
But it depends if your phone is vulnerable or not. Like if there has a patch that needs to be applied, like they update iOS or something, a lot of times they'll fix problems. But if you have an older phone that has some kind of weakness and you don't fix it, there's a lot of them out there.
Hmm.
And you can do all kinds of stuff once you communicate to the phone, have like data go through, you can do a lot. Cellular towers. Ham radio exam. I use FISSURE to help me study for the ham radio exam, and I took it and I got a license. Ham radio. So when you're studying for the exam, they give you the questions and the answers. So it's pretty easy to pass the test if you know what you're doing as far as studying. So these are all the questions. I'll tell you what the answer is.
Is it the same exam every time?
They'll mix up the questions. They'll give you like 30 of them, and they're multiple choice. So it's not that hard to fail, but like if you don't know what's going on, it's hard to remember sometimes. TA8 T8A11. This one. What's the answer? B, 150 hertz. And what I use a study guide called Anki, uh, ANKI on the ham radio. I don't know if it's installed, but what it does is it'll just go through each question, and depending on how hard you think it is, you can say easy, hard, and it'll recycle those flashcards in front of you right on your computer. And it's a good memorization tool for anything, really, as long as the decks, the cards exist. And they do for ham radio. People have made them. So that's what I use. I didn't have to study that long for the exam. I just took a couple hours uh, for like a weekend beforehand. And once I knew all the answers, I didn't get them wrong. I felt pretty good about it. Then right before the test, I did it as a refresher and I got them all right. It's really good for memorization. Let's keep it going. What are we doing? Oh, we're taking forever. What is the cancellation date for that? So when you get a license, they'll give you a number, an FRN number. It's just like a document ID kind of deal. But Fissure has tools where you can look up stuff. License search. You have a call sign associated with your license, which is what you go by for the most part. But then you also can look up other things. This one is for Walter Cronkite, I think. Not to ruin the surprise. And it's asking for the cancellation date. So this is his call sign. I'm not going to say mine because if you know what it is, you can look up like their address and stuff.
Hmm.
Well, mine probably has my old address, so I could probably say it. It wants the cancellation date, this date. He died. That's probably why it was canceled. Yeah. Good stuff. That tool is kind of the important thing from there. That Anki thing for studying. I just did that. Wavelength. What is the quarter wave wavelength of some signal? You can just do 300 million divided by the frequency, give you the wavelength or something like that, or maybe it's the inverse of that. But there are calculators that you can use from Fissure. You can Google it. There are wavelength calculators. So if you do 400 megahertz and you do a quarter wave meters, what's it asking for? What frequency is a quarter wavelength of 0.75 meters? This one, not sure if this calculator is exactly right, but you can do it just with any calculator. 300 divided by something is 0.75. It's 400 megahertz for a full wavelength, and you divide by 4 or something. So it's either like 100, it's probably like 100 megahertz. Or Yeah. Yeah. So wavelength is so you got your frequencies, and if the distance between like one cycle is the wavelength, and that's kind of how people uh say what a signal is. They go by wavelength or by frequency, so they're interchangeable in a lot of ways, and it's important in a lot of calculations for stuff. So that's why it matters. It helps you determine like what antenna size you need for transmitting or receiving. It depends on the wavelength. You guys don't care about that, do you? Probably not. All right. I'm gonna try to do these as fast as possible. Meld. Meld is a tool for diffing files. So it tells you what the difference between two files is.
Gifting is a phrase.
Differentiating, I
Ah.
guess. Downloads. There's a command called diff that you can run in a terminal, and it's the same kind of deal. I use it for merging a lot of things. Like you'll have changes on one side and new changes on the other. Well, you have the original on one side and new changes on the other, and it'll highlight them, and you can just click a button like that, and it'll transfer it to your file. So you can pick and choose which ones you want to merge in, and it spells out flag as you supplicate. Spells out supplicate. It's a Christmas theme. Um, yeah. This is a fun one. This is an audio file that when you play it back, it will give you a code, a message. It's a real obnoxious sound,
Hmm.
and it sounds like a modem. To audio. So there's this tool here for transmitting a data, some signal, and there's a tool here for receiving it. And when you play the audio back into your microphone for your computer, it will decode it. This is probably gonna be loud for people, or it might not be. I don't know. We'll see. I'll take my headset off so it goes into my microphone. Words. Hold on. Sometimes you do it a couple times. Good luck. There it is. So the flag is have a good year. What people used to do is they would put messages into songs and stuff, and you wouldn't be able to hear it, but you could decode them with something like this. So if I put something on top of that, you might not be able to hear it, but you can still decode it. It's people, I don't think do that very much these days. Yeah, good. Here. A couple more then we're good. What is the password in here? What's the password in line 167 of Secless? Secless is a repo that has a bunch of common passwords and usernames for things, and people download them and they use them for cracking Wi-Fi and anything else that needs to be cracked. You can Google it. Make sure you get the right year. 2023. Yeah, it's the wrong year. Three most used passwords. It wants line 167.
How did it like how are all these compiled? Like how do we know these are the most used passwords?
Good question. I don't know. Someone does it. How they do it, I don't know. But if you have any of these passwords, you are not in a good place.
Oh.
And there's passwords for a lot of things. Same with usernames.
Hmm.
So people will just like search them. Admin. All right, we're done with tools. Just these, found these last ones out. X10, it's a fun one. What is the data code value in that signal? That can be downloaded from a collection. All right, archive collection. 1 mega sample per second, all number 3. So you can download the whole folder by clicking it, hit download, or you can download a specific file by clicking it, hit download, shows up. It wants to know the data code. I got another flow graph for this. There are other tools you can use like RTL 433 that'll decode X10 if you play them into them. That looks like it's already set up. Do a file source, plug it into all this stuff. This is something I made, I think, and it will print out a message. I don't think there's any, yeah, there's nothing going on here. My computer's struggling a little bit, but it replays the message over and over again. And it's mostly printing out these values. And it wants the data code, which is 28. Done. Yeah, X10 is a protocol for like light, for like switches, and it's a wired protocol, but there's a wireless version of it. And it's used for like home automation and stuff like that.
Mm.
Z-Wave. We'll find the RGB value. Another Z-Wave 1. Another flow graph for that.
Is that the main protocol for those systems, or it just depends on the manufacturer?
X10 isn't used very much. Z-Wave is like IoT, more popular these days. Z-Wave, Zigbee, um, Wi-Fi is kind of just used for a lot of it. Z-Wave 1. And it prints out a single message. So you'll see bits that kind of look like this. It pulls it apart. You don't have to do anything. And it wants to know the RGB value. So I'm not printing out the RGB value, I don't think. But I have the full hex here. And Fissure, once it's kind of more automated, it actually does do this. You can launch this flow graph in the modulation tab here, and it'll give you a bunch of data, and you can parse that data and apply it to your library and stuff, or you can just copy and paste it into here, and that's what that bit slicing tab is for. But this data viewer tab, you manually do it, you apply it like we did before, and once the RGB value, the answer is 5DFF00. Not the answer here. What's, oh, wrong one. What kind of Z-Wave command class has value 6B? There's a Z-Wave list again. Maybe this one. There's a spec for it, a PDF. And there's just a spreadsheet that some guy made. That lists a lot of the command classes, and it wants to know 6B. What's 6B? So you search for 6B, and it's for irrigation devices. But this is the type of stuff that it'll do, like sensors and security, thermostats, anti-theft. We got transmit and receive capabilities. I did it for a light bulb. I made a video of it where I'm constantly changing the colors and stuff. It's good for giving people seizures. What Z-Wave subtype is listed in the Fissure library as a signal of interest? So I'm not going through like everything that Fissure does. I'm just doing a couple examples here. But Fissure keeps a library of signals that you see, and you can search it and make decisions from it. And I wanted to know what signals in my library at 869 megahertz, what Z-Wave signal. So if you search around 869, plus or minus a couple megahertz, it'll spit out some values. And these are things that I manually entered into the library. And it wants to know what's at 869. It's some bizarre subtype. GKRCH. So just imagine someday that this is all automated. You find signals, you decode them, you search your library, you know what they are. And if you don't know what they are, you can reverse them.
Hmm.
And this tool will help you do it. And someday it'll help you do it fast. Oh God, we took a long time. I'm sorry.
No problem.
All right, so that is the 2023 Fissure Challenge. Nobody really did it this year. We had a few participants, but it's a learning exercise. It's open all year. It will stay open. We'll do it again next December, and we'll do it for a lot of the new stuff that I'm putting in here. So if you are doing it, this video will help you. And if you want to kind of know what's involved in this challenge, this video will help. That's it. Anything else, guys?
No, I
think
don't think so.
Thanks for helping. And
course.
good luck, everyone. Go to the GitHub to learn more about Fissure, and I'll see you next year.